experience in Python and Hadoop and Spark environment. Okay, so as part of today's demo, just I'm going to cover the following topics. What is big? I request everyone to please be in mute. 1 second. Okay, I'm just going to cover the following things. What is big data? Why Hadoop required? Already we have got many technologies available in the market, right? Why again Hadoop? And let me discuss about the current drawbacks. Databases. Drawbacks of databases. Hadoop advantages. Hadoop components. Hadoop job market. Okay. Hadoop and Spark job market, Hadoop advantages, Hadoop components, drawbacks of, but first, what are the drawbacks of the current technologies? Why again we are going for this Hadoop and Spark technologies? Why the current technologies can't they perform? Okay. So if you got any queries, you can just just give your queries. I'll be giving some time at the end of the session. Fine. 1 second. Fine. Okay, what is big data and why Hadoop is required? First, let me discuss what is big data. So if we take currently big data, the name itself saying huge volumes of data. Big data is nothing but huge volumes of data. Currently, how the data is getting stored, what are the data storage units? Currently, data is stored in the form of KB, observe, MB, GB, gigabytes, terabytes, petabytes, exabytes, zettabytes, so terabytes, okay, so on. Petabytes, so terabytes, so on. So from TB onwards, we say it as big data, right? From TB onwards, we say it as huge data generation. So I've got some couple of queries like you should have seen KBs of data, MBs of data, or GBs of data, even TBs of data you should have seen. But do you think like petabytes or exabytes of data, is it getting generated in the current real world? If so, examples of petabytes or exabytes of data generation. So I'm saying like big data, huge data generations, like if you see 1 petabyte equal to 1024 TBs. Do you think like petabytes or exabytes of data, is it getting generated in the current real world? If so, examples of that. I want the sessions to be interactive, like you can just unmute yourself and you can ask, you can just 1 second. Take example of any, if you take example of any banking sector, if you take the example of any banking sector, if you take any bank today, like if you see a branch for in each every street, means within a city you can see hundreds of branches for a particular bank. Within the entire state you can see thousands of branches for a particular bank, right? In the entire state, in the entire country, lakhs of branches for a particular bank, right? So lakhs of branches for a particular bank, and millions of customers, each and every customer, they perform like multiple transactions per hour, per day, per week, per month, per year. Each and every transaction need to be stored, right? So huge data is getting generated, right? Now, forget about that banking sector. Everyone are aware about the social media like Facebook. In Facebook, it has got users not only within the country, but it has got users throughout the world. In a minute, what is the data generation of the Facebook? How many posts and videos are getting circulated? What should be the storage capacity of Facebook? It's not in MBs or GBs, right? In TBs or petabytes. Not only like Facebook. Today if we take any application generating data, it is generating huge data. For example, I'm sorry, if you are taking an application, sorry, Hadoop HA, HA only, it's fine. Observe this. Now, every application generating data, huge data. If I take a 1 minute transaction, just observe how the data generation in a minute, how many FB posts, and what is the data generation of Facebook in a minute. In a minute, Twitter tweets. In a minute, what is the data generated by Google? Data generated by Google in a minute. Huge data, right? Everyone creating their own videos and uploading in the YouTube videos upload. What is the data generated by YouTube in a minute? What should be the storage capacity for handling all this? And millions and trillions of users using email or Gmail messages, right? Email or Gmail messages. So huge data getting generated here. If we talk about the bank transactions, millions and trillions of users making multiple transactions per hour, per day, per month. Okay. Telecom transactions. So if you see everywhere, huge data getting generated currently. For example, if you take e-commerce website like Amazon or Flipkart, so huge data getting generated everywhere, right? Any application generating huge data. So if you take on an average, if you take like Google, it is generating more than 600 petabytes per month on an average. 1 petabyte equal to 1024 TBs, right? But 600 petabytes, nothing but 600 into 1024 TBs. That is what the data generated on an average. Okay. So for storing this huge data and for processing this huge data, we need to have some tools. So for storing this huge data, so currently if I say for storing 1 petabyte of data, so currently we have got some databases. If you observe, we have got some databases like Oracle. For storing data, we have got database like Oracle, MySQL, DB2, all these are the databases used for OLTP, online transactional processing. This database is used for what? Online transactional processing. They can handle GBs of data. But we have got some specialized databases like Teradata, Vertica, Netija. We have got databases like Teradata, Netija, Vertica. They are used for OLAP, data warehouse purpose. They can store terabytes, TBs of data. Okay. But if you take these databases or specialized databases, they can handle data up to some extent. But unlimited data storage is not possible by using these databases or specialized databases. But for unlimited data, for huge data storage, for unlimited data storage, not only storing and processing the data, for that we have got a framework called Hadoop. for storing this huge data, unlimited data storage. But before I go with what is Hadoop and what are the services provided by Hadoop, let me show you the data generations currently how the data generations, different sources of data, different types of data, before actually I go with what the services of Hadoop. If you take the data generation from the last 50 years,
Sir, voice is not clear.
once again, everyone, can you please confirm whether my voice is clear or not? Is this the problem for everyone?
No, 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 no. Voice is okay.
Voice is okay?
Yeah.
Okay, it's okay.
Okay, fine. Okay, fine. So you can just check from your side if there is if it is properly connected or not. So if we check, for example, observe this. This is the data. Think this is the data which is available in the current real world. Okay, which got generated from the last 50 years. 1970 to 2020. So if you assume, compare this data from the last 40 years and the last 10 years, 2010, 1970 to 2010. It's 40 years of data, and compare with the last 10 years, 2010 to 2020. Only like 20% of the data got generated from the last 40 years, but 80% of the data has got generated from the last 10 years. 80% of whatever the data from the last 10 years, but previous 40 years, only 10 to 20% of data has got generated. Reasons for huge data generation from the last 10 years, especially, what is the reason for that huge data generation, especially from the last 10 to 15 years? You say because of usage of technology, usage of smartphones, usage of internet. So everything through internet, so everything through online, like online banking, online shopping, online exams, online education, e-learning, online communication, audio video chattings, okay, online gaming, everything through online. So because of that, huge data is getting generated, right? So previously, if you see in 1990s, or if you see in 1990s, see that data storage, whether you know, like you have got floppy disks, just the size is 1.44 MB. How you used to carry data. Later you got compact disc, later you got DVDs, USBs. But still, day by day, data is increasing enormously. Still, that storage systems also should be increased, right? So, if you see, what are the main sources from where this data is getting generated? What are the main sources from where this data is getting generated? Mainly, I can say three sources from where this data is getting generated. Three sources. Mainly, I can say social data, machine data, and transactional data, I can say. Transactional data. So social data, machine data, and transactional data. Social data means the data which got generated from the social websites, the data which got generated from the social, like Facebook, Twitter, all this. Machine data, the data which got see, for example of machine data. For example, if you go to any shopping malls, for the items you purchased, a huge bill is getting generated, right? So the data which got generated, by reading the scanners, the barcodes, such kind of data we call it as machine data. Okay, which got generated from machines. Simply saying the data which got generated by reading the barcode scanners, such kind of data we call it as machine data. And transactional data. If we discuss about this transactional data, mm, transactional data nothing but day-to-day transactions, like bank transactions, telecom transactions, all this. So mainly three sources. And if I discuss about the types of data, types of data, structured data, semi-structured data, and unstructured data. Structured data, semi-structured, and unstructured data. What do you mean by structured data? The data which is arranged or organized in the form of rows and columns. Such data we call as structured data, which is organized in the form of rows and columns. Examples of structured data like Excel sheets, database tables. Semi-structured data means which is not fully structured, which is not fully unstructured. Example of semi-structured data. Example of semi-structured data like JSON files, XML files. All these are not fully structured, they are not fully unstructured. Fine. Unstructured data, there is like articles, chart messages, images, videos, all they comes as unstructured data. Okay, structured, semi-structured, and unstructured. Fine. So these are the types, mainly three types. But if you see in the currently, we need to have the, see, the biggest challenge is we need to have the tools which can store all the varieties of data. But if you see the current databases, they can handle only structured data, right? Semi-structured, unstructured data can't be handled by the databases, like storing these XML files, JSON files, these things. But Hadoop can handle all the varieties of data, structured, semi-structured, unstructured, not only handling, storing, and processing that huge data in quick time. Okay. So as data is increasing enormously from day to day, so we need to have proper storage systems for storing and processing the data. So as a solution to all this, we have got a framework. We have got a framework called Hadoop. So we have got a framework called Hadoop, which is meant for two things. Hadoop is mainly meant for two things: for storage and processing. Hadoop is meant for storage and processing. Okay. Generally, if you take any technology, it is meant either for storage or processing. If you take any technology, they are going to perform either storage or processing. For example, if you take like C or C++ or Java or .NET, all this they are used for processing. Or if you take Oracle, MySQL, DB2, Teradata, all this they used for storage. Either they are performing processing or storage, but Hadoop performs both storage and processing. That too, huge storage and huge data processing. Huge data storage and huge data processing. Unlimited data storage and unlimited data processing. Okay, fine. I've got some couple of queries. Yeah, Python also for meant for processing. Okay, so unlimited data storage, unlimited data processing. Okay, I've got some couple of queries here. Fine. So when Hadoop can able to store the data and can process the data, then what is the use of the current technologies? What is the use of the current technologies? So whenever Hadoop is going to able to perform both storage and processing, means do you mean that the current technologies, processing technologies and storage technologies will go away from the market? See my query. If Hadoop is able to do both storage and processing, what is the necessity of all this C, C++, Java, .NET, Python, all this? And when it is going to store this data, then what is the necessity of this databases, MySQL, DB2, Oracle, all this? Fine. So when to go for Hadoop? When to go for Hadoop and when to go for, it means Hadoop is meant for huge data storage and huge data processing. Hadoop is not for OLTP processing. One thing, Hadoop is not for OLTP processing. Hadoop is for batch processing. Hadoop is for batch processing. Hadoop is not for online transactional processing. For day-to-day activities or for a single record or two records or 10 records, no need of Hadoop. We can go with current database technologies. But Hadoop is meant for millions and trillions of records, for storing it and processing it. For a single record or for 10 records or for 20 records or KBs or MBs of data, not required. But for huge data, for millions of data, millions and trillions of records, we go for Hadoop. So like if you take the technologies like Java, in real time we use Eclipse. Okay, if I'm providing some GBs or TBs of data or petabytes of data, so it takes huge time. But Hadoop, it is going to process the data in quick time. So just I'll be showing you, I'll be demonstrating you how exactly the data storage and data processing happens. Why only Hadoop can do that? Hadoop can store unlimited data. Why not the databases cannot store this unlimited data? And why Hadoop only can process in very quick time? What internally happens? Internally, what exactly happens? That's it. But for storing the data, does Hadoop use any database internally? For storing the data, does Hadoop use any database? No. Hadoop doesn't use any database for storing its data, but it is going with a special kind of file system called as Hadoop distributed file system. Observe carefully. Hadoop doesn't use any database to store its data because databases has got some drawbacks. Despite of those drawbacks, still we are not going with databases for storing its data. We are going with a special kind of file system called as Hadoop distributed file system. And for processing, does Hadoop use any processing technologies like this Java, this thing? No. Hadoop is going with an execution model called as MapReduce. We have got a execution model called as MapReduce. Okay, but MapReduce previously, if you see in the year 2014, 15, 16, 2012, 13, 14, 15, 16, there was a big hype on this MapReduce. But currently in the market, this MapReduce has got outdated. Previously, there was a huge demand for this MapReduce, but now it has got out. This component has got outdated today. Instead of that, we are replacing this with Spark. Spark. So Spark is an execution model. MapReduce is also execution model. MapReduce execution model was designed excellently, but as compared with Spark. See, Hadoop processing speed. If you see the Hadoop processing speed with any other processing technologies, you can just check how the Hadoop process. Just let me. So there is a query asked like in vernacular Teradata, we could store and process data. Is it? What are the things indicated by data processing, ETL load, or data business logic calculations? Yeah, extracting, transformation, and loading, or data business logic or calculations. Okay. I'll come back to your query. Yes. So for processing, we are using MapReduce. Still, we are some of the companies going with MapReduce, but mostly like Spark is preferred today. Very high speed processing, we can say. Petabytes of data or higher data, huge data. If you want huge data, if you want to store, and if you want to process, Spark can process in minutes or seconds. Very high speed processing, we can say. Spark. Okay. So for storing, we are using HDFS, and for processing, we are using MapReduce and Spark. MapReduce and Spark are used. Okay. So Hadoop providing two services. One is storage and one is processing. Storing the data and processing the data. It does both storing and processing. Okay. Now, yeah, some queries were asked like why only Hadoop can store huge data? Why not the databases? Why only Hadoop can process that data in a very okay? Let me discuss. So if I take the databases, current databases, first thing, let me discuss the limitations of databases. Observe this. Drawback of databases. First one, limited storage. Unlimited storage is not possible. Limited storage in GBs or in petabytes. In most of the databases, no parallel processing is going to, in most of the databases, no parallel processing is going to happen. And if most of the databases, if volume increases, speed decreases, I'm saying. So in most of the databases, if volume increases, speed decreases. For example, just justify this, if volume increases, speed decreases, I'm saying. Let me take some queries and show you this. Select, see this SQL query, select sum of amount from sales one. Select sum of amount from sales one, the same statement I'm taking. Select sum of amount from sales two. Select sum of amount from sales one, select sum of amounts from sales two, select sum of amount from sales three. Three tables I am taking. I want the total amount from the sales one, sales two, and sales three. Sales one, think of that I've got some 10 records. I got some 10 records. Here 1 lakh records you got. Here 1 crore records you got. Now can you please answer which query is going to execute faster? Which query is going to execute faster among these three? Total amount of 10 records, or 1 lakh records, or 1 crore records? Which query is going to execute? First query is going to execute faster, right? the total amount of 10 records as compared with 1 lakh records or 1 crore records. So from record to from query to query, as volume increasing, speed decreasing, right? Okay. The other example, see this. In databases, complexity increases. If complexity increases, speed decreases, I'm saying. Speed decreases. If you take a labor example before this, for example, just try to answer what is 3 into 4? 12, you say. 5 into 9? 45. 13 into 8? What is output? 123 into 756? 6574 into 9876. So if you see this human mentality, if that complexity increasing, speed decreases. Whenever I say 3 into 4, immediately you are saying 5 into 9, you are saying 13 into 8, you will be able to say. But so as complexity increasing, speed decreasing. But as database point of view, if I discuss as complexity increases, speed decreases, let me take some queries and just justify this. Okay. If you observe, I'm taking this query, select sum of amount from sales. Just the table name is sales. Only one table I'm taking, sales. Observe this query, which query is going to execute faster? Now, select the average amount from sales. Select a standard deviation of amount from sales. Same table, you are applying the same thing, total amount from sales only. Think that same table, average amount, standard deviation of amount. Which query is going to execute faster from all these three? Which query execute faster from all these three? Total amount from sales, average amount, standard deviation of amount. Again, this first query execute faster, right? Okay. The second query, if you take average amount, is a two-step process, right? First sum to be calculated, next average to be calculated, takes more time as compared with the first query. Third query, if you observe, third query, lot of internal processing, standard deviation is lot of internal processing is required. So here query to query, complexity increasing, speed decreasing, right? Okay, the major drawback of databases. Now see the fifth one. The major drawback you see here, can handle only structured data. Databases can handle only structured data. Okay. For example, observe this. Just I'll take one example. Can handle only structured data, I said, right? For example, I want to take reviews for a particular movie. Reviews. The table name is reviews. And here, if you see, this is the table. User 1, user 2. So 100 users are giving that feedback or the review. Okay, see that column name, user and review. Now user 1 saying that movie is good. If movie is good, saying 1. If movie is bad, saying 0. Movie is good, saying 1. Giving the feedback in the form of ones and zeros. Assume that movie is good, saying 1. Movie is bad, saying 0. Now can you please answer, can you count the number of ones and zeros by writing a SQL query? Can you count the number of ones and zeros by writing an SQL query or not? Count aggregation in database in SQL, we have got count aggregation, right? Now can you please say select single grouping, single aggregation, we say review wise count star, I want count from which table? Reviews table. select review comma count star from reviews, group by review. Select a review as count I want from reviews table, group by review. So if you see the output, review wise means reviews 1 and 0. Count, think that 90 people saying the movie is good and 10 people saying the movie is bad. So this is the output you got. So 90 people saying movie, 10 people saying movie is bad. But generally, if you take real-time scenarios, like generally they won't give reviews like ones and zeros, right? They will give that feedback in their own text format. So first person saying like movie is good, second person saying movie is not good, third person saying movie story is not good. So whatever it is, they are giving in their own text format. Now can you write an SQL query to count the number of goods and number of not goods? Can you write an SQL query for this kind of data? Previously, the data is structured in the form of ones and zeros, but here people saying in their own text format. Now, can you write an SQL query to say that number of goods and number of bads? So even if you are counting, even if you are if just like a keyword count, like good, how many goods? But it gives wrong computation where even not good also has got good, right? So it gets wrong computation. So this kind of data can't be handled. This kind of data can't be handled by using these databases. So just I was saying the drawbacks of databases as compared to Hadoop only. Once again, as compared to Hadoop, but databases will be running in the market. But even if you see in the coming days, we are going to see NoSQL databases. NoSQL databases rather than databases. NoSQL databases today, if you see in the current market, has got great demand as compared with NoSQL database. Sorry, as compared to databases, we have got NoSQL databases. The next generation databases we can say as NoSQL databases. Schemaless behavior, random access. So in NoSQL databases, record to record, a different number of fields can be maintained. My first record can have 3 fields, second record can have 5 fields, third record can have 10 fields. But in the case of database SQL, like Oracle, from first record to last record, same number of fields can be maintained, right? But here, record to record, different number of fields. We have got many NoSQL databases. Like if you they are categorized into many types, like key value store, document store, graph store, key value store, columnar store, document store, graph store. We have got many NoSQL databases like Cassandra, HBase, MongoDB, CouchDB, React, Peanut, many NoSQL databases. Okay, fine. As part of our course, I'm going to discuss on NoSQL databases. So as a Hadoop and Spark developer, you need to have the knowledge of at least one NoSQL database. So these are the drawbacks of databases. Despite of these drawbacks, still Hadoop doesn't use these databases for storing its data. Rather, it is going with a special kind of file system called as Hadoop distributed file system. So there are a lot of things you need to observe. Why only Hadoop can store huge data or unlimited data? How this Hadoop distributed file system, what exactly, how exactly Hadoop is able to store the data? And observe this. Just I'll give like a once. Let me check before I go with advantages of Hadoop. Before I discuss advantages of Hadoop, let me discuss to understand the advantage of Hadoop. First, you need to know the architecture of Hadoop. But just as of now, I'm just going to give overview of this architecture. But in brief, we'll be discussing later. But Hadoop follows master and slave architecture. Hadoop follows single master, multiple slaves. Master and slave architecture. It won't follow client server architecture, single master, multiple slaves like this. Single master and multiple slaves architecture. This we call it as master node. Okay. This we call it as slave nodes. Master node, or we call it as in Hadoop terminology, we call it as name node. Slave nodes are data nodes, we say data nodes. Observe this, data nodes. Why we call them as data nodes means in Hadoop, data stored by the slaves, data processed by the slaves. Just I'll give a quick example like how exactly data is stored and processed, but later I'll give in brief, I'll discuss in brief how what happens internally. In Hadoop, data is stored in the form of files. Think that I've got this 1 TB, 1 TB, 1 TB. But think this file size is like 3 TB. Can this 3 TB file, can it fit into any of the slave, S1 or S2 or S3? Not possible, right? So it cannot fit into S1 or S2 or S3. So in Hadoop, you are just going to split it. You are going to split the data into blocks. You are going to split the data into blocks. Each block stored in one slave. Each block stored on the blocks. Data is going to be split into multiple blocks. The blocks are going to get distributed across the slaves. The blocks are going to get distributed across the slaves. That's why here data is getting distributed across the slaves. Hadoop distributed file system. Data is getting distributed across multiple slaves. Think that 3 TB means, think that here you got some 30 lakh records, assume. Here 10 lakh records in this, 10 lakh records in this, 10 lakh records are stored, assume. Means data distributed across multiple slaves and data processed by multiple slaves parallelly. Here only 3 I have taken. Think that if you have got like 30 slaves, data distributed across 30 slaves, data processed by 30 slaves parallelly. So that data is executed by 30 machines parallelly, more speed. So work done by a single slave and work done by 30 slaves. See the difference between the speed. Work done by a single person, work done by 30 persons parallelly. See that difference between the speed. Okay, the same here also. Parallel processing, 30 systems running parallelly and executing a single job, that is single what is data file, and data is getting distributed. See, if your data is increasing, your slaves will be increased. For example, today if I am running a business with only 10 slaves, 10 systems, but your data has increased, branches have increased, then you need to increase your number of slaves. Fine, that's what. Okay, now coming to this, I just discussed like drawbacks of databases. Like now coming to the Hadoop advantages. Hadoop advantages. First one, unlimited data storage. What is that? Unlimited data storage. Unlimited data storage because of a feature. Because of a feature. Horizontally unlimited scalability. There is a feature horizontally unlimited scalability. Okay, horizontally unlimited scalability. What do you mean by horizontally unlimited scalability? Means, observe this. Horizontally, you can keep on adding the slaves. Unlimited number of slaves can be keep on adding. There is no limit on the number of slaves you are going to add in Hadoop. You can keep on adding the slaves. If the data is increasing, and if that customers are increased, if branches are increased, if data is increased, the number of slaves also should be increased. If data increased by 100 times and customers increased by 1000 times, you cannot go with the same number of slaves. You will be increasing the number of slaves. So the data is going to get distributed across the slaves and processed by multiple slaves parallelly. Fine. horizontally unlimited scalability. And second advantage, Hadoop advantage is very high speed processing. Very high speed processing. Very high speed processing because of parallel processing. Because of parallel processing. A label first, let me give a label example. What is this parallel processing? Most of the databases doesn't follow this parallel processing. For example, let me give an example of parallel and non-parallel. Parallel and non-parallel. Okay. Parallel processing. For example, one person preparing one item takes 1 minute. If same one person preparing 10 items, how much time? 10 minutes, right? One person preparing 100 items takes 100 minutes. See, but in the, sorry, this is non-parallel, this is non-parallel, and this is what? Parallel. In non-parallel, one person preparing 100 items, 100 minutes. But in the case of parallel, one item takes 1 minute, 10 items also takes 1 minute, 100 items also takes 1 minute. Means here 10 persons working parallelly preparing 10 items. Here 100 persons working parallelly creating 100 items, 1 minute. Means here we are saying like items, but in our terminology, systems. 100 systems running, here 10 systems running parallelly. So here in parallel processing, the speed is not going to decrease. That is what parallel, very high speed processing you are going to see in. Third one, can handle all varieties of data, all varieties of data, structured, unstructured, and semi-structured. And Hadoop is an open source. Hadoop is an open source, no licensing required, fast cutting. And Hadoop uses commodity hardware. Means it doesn't mean that we need to have the latest configuration, high configure, commodity hardware, any hardware. Okay. So let me discuss about this first two, mainly these first two features. Unlimited data storage, very high speed processing. Okay. Just 1 second.